This is a new topic in block 4, electric current. Block 4 is about electricity and magnetism. So there are things which are related, or there's a relation between electricity and magnetism. So first, what is electric current? Electric current means it is rate of flow of the charges. When the term rate is there, it means it is how many charges are moving through a wire in 1 second, or you can also say it is number of charges moving through wire in 1 second. So example, say this is a wire and the three charges are moving from one end of a wire to another in 1 second. So what is the current here? If three charges, in this example, if three charges or 3 coulombs in 1 second, so current is basically how many charges are moving in 1 second. So 3 charges in 1 second. So what is the current? The current will be 3 ampere. The SI unit of the current is ampere. Or rate of flow of the charges. Another wire which is having, say, 5 charges are moving in 1 second through the wire. What is the current in the second wire? If there are 5 charges, so if the 5 charges are moving in 1 second, so the current will be 5 ampere. So both these examples, we have the time interval as 1 second. But for example, if the time interval was not 1 second, example, you have a wire and this wire, 3 charges move in 2 seconds. So if 3 charges flow in 2 seconds, what is the current here? Current is how many charges flow in 1 second. So if 3 charges in 2 seconds in 1 second, it means half charge is there. So the current will be 1.5 ampere. So current can be in decimal as well. So rate of flow of the charges or the number of the charges which are moving through a wire in 1 second. So if you want to calculate a current, so what the formula to calculate a current is calculated by formula which is charge divided by time. Symbolic representation, current is represented by symbol I, charge is represented by Q, it's not C, the unit is coulomb, that is C, but it is represented in the formula by Q. So I is equals to Q by T. And the unit of charge, unit of current is ampere, unit of charge is coulombs, and unit of time, the SI unit of a time is second. Is it clear the concept of current, electric current? Current is represented by symbol I, and the unit is ampere, denoted by A. But when we use a formula, we say I is equals to Q by T. But for example, if you have electron, one electron, how much charge it carry? One electron carries 1.6 into 10's power minus 19 coulomb. That is a charge which one electron carry. So if electrons are flowing, like if one electron is flowing, it carry 1.6 exponent minus 19 coulomb. So it carry this much charge. Now, if a question is calculate the current flow through a wire when 6 exponent 20 electrons move through a wire in 4 seconds. So calculate the current when 6 exponent 20 electrons flow through a wire in 4 seconds. So to calculate the current, we have the formula current is equals to charge. So current is equals to charge divided by time. This is the number of electrons, but this is not the charge. The one electron carry, the charge on one electron is 1.6 exponent minus 19. So first what we have to do, we have to know the total charge. So what is the charge here in this example? The charge is equals to the number of electron, which is 6 exponent 20 multiplied by charge of 1, because that will be the total charge, 1.6 into 10 power minus 19. What is the answer here when you multiply these two numbers? 6 exponent 20 multiplied by 1.6 exponent minus 19. The final answer is 24. That's but what is the answer here for this part? That is 96. So the total charge is equals to 96 coulomb. So this is a charge carried by this many electrons. And but I need a current. The current is charge divided by time. So current is denoted by I, charge is denoted by Q, and time is T. So I, the current, is equals to charge, which is 96, divided by time, it's 4. So 96 divided by 4, that is equals to 24 amperes. So the final answer is 24 amperes. Is it clear? the calculation, because one electron does not carry 1 coulomb, one electron carry 1.6 into 10 to the power minus 19 coulombs. So the total coulomb will be the charge of one electron multiplied by total number of electrons. So we'll get the total coulomb, the total charge. Solve another example. Calculate current when 30 exponent 30 in multiply 10 power 24 electrons move through a wire in 4 milliseconds. Solve this example, calculate, and that's a fixed value for a coulomb. That the charge, this will be given, you don't have to memorize this value. In exam, it will be given to you. But if you learn, it's good. 1.6 exponent minus 19 is the charge of one electron. What's our final answer? A hint, first you will find the total charge and then divided by time interval. But this time is millisecond. Milli means 10 power minus 3. So actually this time is equals to 4 into 10 power minus 3. Because the term milli is a prefix used for exponent minus 3. So 1200 amperes. Is it same for everyone? So first what you will do, you will find the charge, the total charge. The charge, this many electron, 30 into 10 power 24 multiplied by 1.6 into 10 power minus 19. Okay, I will see, like I will check this part, minus 19. What is the answer for this calculation, this part? When you multiply 30 into 10 power 24 with 1.6, so this is the answer for the charge. But you don't need charge, you need a current. So the formula for current is equals to charge divided by time. So current is equals to charge. What is the charge? Divided by time, because it is 4 milli, so it is 4 into 10 power minus 3. So when you divide, it is 1.2 exponent 9 ampere. So the final answer is 1.2 into 10 power 9 amperes. when the number is too big or too small, it's better you write in exponent. Like if a number, even if it's very small number, like 0.0000125. So it's for these type of number, when too small or too big, better represent in exponent or power of 10. Current in a circuit, first thing, circuit is the region where the charges can flow. The region, the place where the charges can flow, that is known as a circuit. And a circuit is divided into two main categories. One is known as series, another one is known as parallel. Series circuit means only one way for the charges to move. And parallel circuit means multiple ways for the charges to move. Example, say I have two lamps. This is a circuit symbol for the lamp. So I have two lamps and I connect one next to the other. And this is a symbol for the cell. If one big line is representing the positive terminal of the cell and small line is representing the negative terminal of the cell. The direction of the current is always from positive to negative. So when we consider the direction of the current, but in reality, there is nothing moving from positive to negative, and the direction of the electron is from negative to positive. But because all these circuit laws, electricity laws are derived for the movement from positive to negative. So whenever a question is there, show the direction of the current. So you will always show the direction of the current from positive to negative. This is just assumption, which is also known as conventional current. This is having a specific name, which is also known as conventional current. But in reality, there is nothing moving from positive to negative in the circuit. Actually, all electrons are moving from negative to positive. But we always take the conventional current because the circuit laws are derived with the conventional current. So if I say state the direction of the conventional current, so how the conventional current will move? It will move from positive to negative. And you have another circuit in which the two lamps are connected separately to the supply or the battery. So we have a positive and negative terminal. If I say state the direction of the charges, movement of the charges, so they have multiple ways to move. So they can move through the first lamp, which is closer to the battery. They can move through the second lamp and then return to the battery. The direction is always, the conventional current is from positive to negative. So series circuit, you can see the charges have only one way. There's no other way or other passage for the charges to move. But in parallel, they have multiple ways. They can take path one, like if this is representing a charge. So when the charge is entering, the highlighted part is represent. So this charge is having two possibilities. It can go up or it can move in the second branch. So it can return back. Or if there's another charge which enter, it can go up, flow through the component and then return back. So but here the charges have only one way. The moment the charge enter, it can only flow through this path and return back. So only one way. When the charges have only one way to flow, we call that kind of circuit is series. And if charges have multiple ways to flow or multiple ways to move through the circuit, we call that as a parallel circuit. Parallel circuit is having an advantage. What is the advantage of parallel circuit? Because what happened, example, if this lamp is faulty, if this lamp is not working, L1 and L2, so two lamps are there. So if two lamps are there, L1 and L2, but for example, L1 is faulty, L1 is not working properly. So if L1 is not working properly, what will happen to lamp 2? Will it work? Yes or no? If lamp 1 is faulty, lamp 1 is not working. What happened to lamp 2? Will it work? So lamp 2 will not work. So the charges cannot flow. That's right. Current won't reach or lamp 2 will not work. So the disadvantage of using a series circuit, if one of the component is faulty, even for example, if lamp 2 is faulty, for example, lamp 2 is faulty, lamp 1 will work, yes or no? So it will not work. Why it will not work? Because the current need a continuous passage, a complete passage. So even one of the component is faulty, the other component will not work. So if one component, the other components will stop working. So that is a disadvantage. So if we connect them in series, if one is working, the other will stop work. It will not, if one is not working, the other will also remain off because there is no complete passage or the path for the charges to flow. But what happens if two lamps are connected in parallel? So you have lamp 1 and lamp 2, they are in parallel. If one of the lamp is faulty, example, lamp 2 is faulty, what will happen to lamp 1? Will it work? So lamp 1 will work. Why the lamp 1 will work? Because there's another passage for the charges to flow. If this passage is not available, it can flow through the other passage and return back to the battery. So the advantage is that the advantage of parallel circuits, that if one of the component is faulty, the other component will continue to work. So that most of our circuits, when we use them as parallel circuits, so that if one is not working, one component is not working, other will continue to work. Is it clear, the concept of the circuits? The circuit is basically a region, the passage, the path where the charges can flow, and a circuit can be divided into series or parallel. Parallel means multiple ways are there for the charges to flow, and series means that they have only one way to flow in the circuit. Then effects of the current. This part we will discuss next class, but I'm just mentioning the effect. So effects of current: when the current passes through the wire, it is having three effects. Number one, heating. When a current is passing through any device, any component, it produces heat. That's why, like example, if you are charging your mobile, you will find after some time your mobile will become hot. Or if you are using, say, a television, or it switched on for a longer period of a time, so you will find it will become hot. Why it will become hot? Because whenever the current is passing through a wire, it always produces heat. And we use this heating effect, the electrical heaters. As in winter, you are using electrical heater. So basically, the wire is there, and through a wire, a thin metal wire, when the current is passing, and that current produce heat and can provide a heat energy to us or work as a heater. So current is having a heating effect. Current is having a magnetic effect. When the current is passing through a wire, it produces magnetic field. This part we will discuss in detail. And whenever current passes, it can also have a chemical effect. Using a current, we can carry out a chemical changes, as we discussed in chemistry, electrolysis and chemical cell. So in electrolysis, what we do, we pass the current, and by passing a current, we can chemically change the substance. So these are the three main effects of the current. Current can produce heat, current can produce magnetic field or magnetism is there, and current can produce chemical changes when passes through a substance. So basically, the current is the rate of flow of the charges, and there are conventional current is from positive to negative, electron flow is from negative to positive. So I will continue this explanation next class about the current. Still, there are some topics are left, so I'll explain this next week. Any question related to the class today? Even for example, when you're using a device, like you're using a mobile for some time, like, so that mobile also become hot. What is the reason for that? Even a laptop, even you're not charging, but because what happened, a laptop, the charge, it is drawing the charge or the current from the battery. So the battery is providing a charge. As the battery is providing a charge, whenever there's a movement of the charge, there's a current, and that current will produce heat energy. That is why even though you're not charging your laptop, but it will become hot after some time, because there's a movement of the charges. This time the charges are moving from the battery to the electrical circuit of the laptop. So I'll end the session and share the recording with you.